What is a quantum computer? You've likely heard about these magical devices that will change the face of computing forever. But what exactly are they? A quantum computer is much like a normal computer in that you can get it to perform a wide range of tasks depending on the algorithm you run on it. These algorithms are run on qubits, which, like bits on a normal computer, have base states of 0 and 1. However, qubits have two unique properties. Superposition. Superposition effectively allows a qubit to be in a probability of both 0 and 1 states until observed, meaning a single qubit can store vastly more information. Entanglement. Qubits are quantum particles, which means they exhibit entanglement. Entanglement is really just when multiple quantum particles are tied together, even despite distance. If something happens to one, it affects the other. These properties allow quantum computers to store and calculate much more data than a traditional computer, and much faster too, as these properties also allow us to build quantum gates, or special algorithms that can manipulate all the qubits in a system in order to get us the answers we need from a quantum computer.
Thanks to superposition, we can sort of run many calculations at once and gather different predictions for a solution. We can manipulate qubits in a precise and controlled manner so that more accurate predictions dominate through constructive interference and less accurate predictions deteriorate from destructive interference. The result is that we get a very high probability that when we observe the system, the solution we get is the solution we want. Quantum computers will not replace traditional computers. Quantum algorithms are hard to come up with, and in many cases, optimized traditional algorithms are faster. They're useful in several calculations, but there are three typical examples. Factoring large numbers into primes. Factoring problems can be reduced into a simple pattern-finding problem that quantum computers can run quickly. Large, difficult-to-factor numbers are the basis of many modern encryption techniques. Searching through unstructured databases. Big data is everywhere, and a quantum computer's ability to handle many inputs make analysis much faster for large datasets. Quantum simulation. It's easier to simulate quantum systems when you use a quantum system. This is particularly important for material science or drug discovery. The primary concern comes from error handling. In any system, due to the nature of physics, random errors will occur. Quantum computers have many parameters, so more potential errors. Qubits are continuous, and it's nearly impossible to exactly measure and correct continuous values in nature. Many argue that due to this simple fact, it's unlikely that there will ever be a truly useful quantum computer. However, mitigation can help with errors. There's already been significant progress, with Google recently achieving quantum supremacy, meaning they used a quantum computer to solve a problem that would take an unreasonable amount of time on a classical computer. Further milestones are also possible with more research. This is the nature of science, to explore and study new ways of doing things. Not everything will work out or immediately be useful, but the pursuit of knowledge is one of the most meaningful pursuits of life.